I'm Phil, and today I'm going to look at three cameras from M5Stack. They all use the same architecture. They run on the Linux operating system, and they all can run the same software. The only difference is the way that they mount their lenses, and I'll briefly show you the differences. Okay, so let's have a look at the Unit V2 that uses an M12 lens. So let's have a look at it now. This is what it looks like. It comes with two interchangeable lenses, and it can be used in conjunction with M5Stack computers, and it has a Grove interface for that. So it does a serial communications between the two of them. Has a fan, and it has a pretty powerful processor. Cost-wise, it's quite expensive. It's $95 US, and mine arrived on early November. So I've actually put it to use in quite a few applications since then. So let's have a look at it. The processor-wise, there's what the processor looks like. Bit of an unusual one, Sigma Star, and it runs Linux. Looking at the memory, it's a little underpowered for a full-blown Linux system, but it does have an additional 512 nano flash. But I'm not sure how the program splits my code between the two of those. So, but you still have to be careful about what you can fit in. Sensor-wise, it's got a color camera and a microphone. The lenses, well, you get two lenses and you can change those. One's a wide angle and the other one is a regular photo lens. You can also run Wi-Fi, and it has an unusual way of simulating a Ethernet LAN connection using USB. So the development method, it comes with already it has AI image functions from QR code face detection all the way through. Quite a good range, and these are very useful. I would say it's more than just a demo, although that was its original intention. You can also use these as part of your development environment. It has UI flow, and the idea is that you would use one of these, like, say, shape matching of an object, like a circle, a triangle, a square, and the UI flow would use its serial port and JSON format to allow you to do additional processing of an image or any of these other programs that you want to use. So what's really nice about it is that the Linux system and the camera are supported with OpenCV. That's really fantastic because you can learn OpenCV using this camera and environment. But in addition to that, you can communicate via SSH or a terminal, and also Jupyter notebooks. And I find this quite fantastic for testing my doing unit testing. Application-wise, well, you could use it for AI recognition. Even in an industrial environment, it could, it's almost as good for doing that. And for those people that would just want to learn the basics of machine vision, it's really good for that. So what else can we say about it? This is what you get in the kit. And the comparison, since you get three cameras which are very similar, so there's the Unit V2, and a more recent one is the Unit V2 M12, and that's the one we just looked at previously. But there's another one which is very interesting, and that's the Unit V2 USB. It doesn't come with its own lens or camera. You just connect a USB camera, and we'll have a look at that one later where I'm connecting it to a digital microscope. So here are the specs, and we've gone through most of those already. Uh, it's open source, and you can actually see what the architecture looks like. And uh, the one that I mentioned on the land is on the bottom, where we have a USB connection that turns internally into an Ethernet connection. And with the right drivers, your Windows PC will treat the AI camera as a device on your network using Ethernet. And it does have accessories. I do recommend the Clip B brick stack for mounting the camera onto Lego. And this makes it very functional and easy to support on your Lego Technic projects. So we might go across and have a look at some of the other aspects like software. That's the hardware. The communications wise, you've got a choice of Wi-Fi, and it has a Wi-Fi web server on the camera. So you just use Chrome, and you can access the unit that way. So in addition to a user login, there's also a root login, which you really need if you want to do any serious AI development with Python. Okay, so we'll move across. I've got UART, and you can find that on your Windows PC quite readily. And the interesting one is the Ethernet to USB, and that works nice, quite well. Software-wise, we've got a choice. You can start off with a simple web server and pick that up on your Chrome browser. That software will keep you going without anything else for some time. Quite good. I like that one and recommend it. There's firmware. So if you damage your operating system, you can re-image that onto a card and then upgrade your computer. The camera will do streaming straight off, and that works quite well. We've also got things like object detect with YOLO 20 class, or a nano detect with a class of 80 objects, and they work quite well. So I've got a number of those. Okay, so we might open that up and give you an idea of some of the things it can detect. So it can detect any one of these objects quite readily, and it does that quite accurately. So I'm quite happy with the results. No problems. All of these images are from my Chrome browser. So it's not an optimal vision system, and sometimes the background is a little bit distorted, but in many cases it worked quite well. So you can see that this one works quite nicely. And that's just using the firmware that comes on the camera. And what else have we got? We've got, you can do some extra training. Now, what's also very nice is the Jupyter notebooks. So if you take an example, if you just want to switch on the LED on the camera, well, this is all you have to do. And that will work immediately. And on the camera, you've got other programs that you can look at the image, capture the image from the camera, and see it on a computer like your Windows PC. Okay, so they're all very nice. So I've done quite a few projects with them, and the one I'm going to focus on, I've done an object detect. There are good and bad points about my experiences with that. I think some of the best experiences are with the Jupyter Notebook, not with the programs that come from M5Stack, but actually exploring and discovering OpenCV. So I've gone through quite a number of all the programs, many of the programs from the book, and we'll see that book in a minute. So let's have a look at some of the programs. So I've been looking at how I could do very basic image manipulation, and I've been able to take the code, have a look at it, and then put it onto a Jupyter notebook. So this is what the code looks like for that particular and the results. I was able to get successful results in rotating images. Now you might notice that you have to put in additional statements to get it into a proper RGB format, because that's not the native OpenCV standard. Okay, so all of those work quite well, and I might actually do a revision on that when I go through all of the chapters. So I finished chapters 1, 2, and 3, and I'm going through chapter 4 at the moment. So you can see some of the topics that I can cover. Things like erosion, dilation, opening and closing of my images. And even further on, I can look at histograms, segmentation, thresholding, and perhaps some of the later ones, even when we look at, it will cover neural networks and deep learning networks. Okay, so that is a worthwhile experience, particularly if you want to learn OpenCV. Okay, so my latest one has been with UI Flow and getting the camera, the AI camera, to communicate with a M5Stack Core computer. So we might look at this one in detail, and we'll have a look at the software and my experiences with that program. Okay, all of the other ones work quite well, but not all of the programs. Listen, I did have some problems with object detect. So bearing in mind, you have to get two programs to work here. You've got to get the UI flow and configure the camera so that it's in object recognition mode, then use the UI code on your core computer for further action. Okay, so we'll go ahead and have a look at the QI code in the next video segment. Here we have the AI camera and core computer. The core computer is currently being able to detect one QR code, and it's using as a feed a data from this camera, and the camera is looking at this image on my screen. So the image is my Facebook account, and I'll just bring we'll go across to what that looks like using the web server software from the camera. So I'm doing code detect, and this is the detection that I'm able to observe. Here I'm generating a QR code to access my Facebook account. So I'm using this program called Code 2 QR Code Desktop Reader and Generator. And I want my hardware, that is the AI camera, to recognize it. And to do this, I'm going to couple a core computer with an AI camera. And here's the code for doing that. So you can see on the left is the user interface. And you look at the unit, it's connected to port C. And we'll go across and have a look at the operation of it. Here is the color tracker, and what we're doing is getting it to track this ball. So as I move around, move the blue ball up and down or back and forward, we'll go across to the screen and you can see how it's being tracked. And there's also a JSON output on the bottom. So if I can, it's tracking that object quite well. This is my motion tracker setup. And we have a Unit V2 camera on the front, and on the back we have a Core computer, both from M5Stack, and it will give us the details on the screen once we start tracking an object. So what I'm going to do is get a coloured ball and track that across the screen. So as I track it, you can see it on the screen over here. So when there's nothing, and when I'm tracking, you can see the details on the screen here. And we also get a JSON output. So if we scroll this down, you can see the results, not only visually, but also we get the JSON result. So I'm now tracking again, and you can see that we're getting the X and Y coordinates for that. We might actually scroll up a little bit more and see if we can get a bit more detail. There we go. We've got some detail of multiple objects. And the code for doing that is over here. So we've got the UI flow and the UI interface on the left. And that's the motion tracker. This is the shape detector configuration. And we have a Unit V2 AI camera looking at the screen, and the camera is also feeding the data to two locations. One is a Core computer, and it's telling us the details of the area and the center of the shape. And we have that also on the screen here with the camera's web server. So what we can do, you can see that it's detecting circles, detecting a rectangle, even if we change the color of that. And it's also trying to detect different shapes all on the one image. And in addition to that, we get Okay, so let's examine some of the good and bad points and what my recommendations are. So the good points, it's, I think, quite powerful based on the Linux operating system, although it is a stripped down version and there's no compilers provided. So you might find it a bit difficult if you want to do more complex image processing. Software-wise, you've got Linux. The demos are more than just demos. They're quite practical. They work very well. And also, I found that treating the camera as a unit or a core computer allows you to use UI flow, and it works. Most of the programs work quite well. This particular version has good optics, and you've got a choice of 2 different lenses, and you also have a choice of 3 different ways of communicating. So I've mentioned 2 of them there. It has mechanical mounts, and that's very handy when you want to mount the camera onto your Lego Technic projects. Some of the bad points, I feel that this particular model overheats, and it probably has a worse performance compared to the original Unit V2. And for many of the projects, I use the original unit. Cost-wise, it's quite expensive. Documentation-wise, you get a minimal amount of documentation. There are a few tutorials and examples, and these can help you go. I don't see any of the published libraries or background, but so far I've been able to survive on what documentation has been provided. Software-wise, well, there are many things that you can't do, although I've overcome some of these, including this one. This is no longer a problem. Cannot read a file. I can read a file now, so I might get rid of that point. Score-wise, I'd give it about 6 out of 10. Very usable, and I find it so far one of my best cameras. But despite that, I think you're probably better off with the Raspberry Pi AI camera because it supports OpenCV too directly. If you're interested in the camera, plenty of references. Go across to the site on the shop. We might go across and have a look at that now. So there's the camera, $95, and it's still available. And it's the latest version of the more powerful cameras available. And there is a wiki. What you also have to really learn is the lab model for color. And it's very close to representing real human vision perception, but it also does support RGB color models, and it takes those color models as one aspect of AI color vision. So yeah, and OpenCV is another area that's worth having a look at. And you might like to compare this camera with the best camera that Seed Studio has, both using the Linux operating system. Okay, so that's it from me, and stay tuned for a few desktop demonstrations.